All right, class, in this video, we're going to be talking about the transformation of inverse trig functions and kind of graphing those. So one strategy to graph the transformation of inverse function is to find the inverse function. So that's going to be a first step. So we're really doing this in 3 steps. So the first one is to find the inverse function. The second one is to create a table of values. And then the third step is going to be to then invert those values into the graph. So let's take a look at an example to kind of see this strategy in action. So here's our 1, 2, and 3. And so if we take a look at these examples, they're kind of labeled by those steps. So starting off with the instructions say to graph f of x arc sine of 2x. So let's go ahead and first find the inverse of this function. So the very first thing we're going to do when we find inverses is we're going to set y equals to arc sine of 2x. Okay, and so the first thing we want to do is we want to swap the x and the y. So we're going to get x equals arc sine of 2x. 2y. We're flipping that. And now we want to solve for y. So notice that because I have the arc sine, right, this is a function. So how do I undo the arc sine? Well, I'm going to apply, I'm not multiplying, I'm applying the sine function to both of these. So now I end up with sine of x. And remember, sine of arc sine, those undo each other because they are in fact inverses, equals 2y. So now I want to get rid of that 2. I'm going to divide both sides by 2. So I end up with y equals 1/2 sine of x. Now, this is a nice way to kind of graph this because I know what the sine of x values are. We can definitely use the unit circle to kind of help us out. So one thing to remember is arc sine is defined, right? It has a restricted domain. So the domain of arc sine is going to be from negative and then the range of this function is going to be from negative pi over 2 to pi over 2. So remember, because we're now looking at the inverse, and so this y is essentially the inverse of the original function, we know that this is going to be restricted to a domain of negative pi over 2 to pi over 2. So we need to keep in mind those restrictions. So this is the domain of our inverse function. Okay, so what does that mean? So that means that when we come over here to graph it, our domain, it tells us that we only have values from negative pi over 2 to positive pi over 2. So I'm just going to evenly space it. What's halfway between negative pi over 2 and pi over 2? Well, that's going to be 0. Halfway between negative pi over 2 and 0, that's going to give me a negative pi over 4. And halfway between 0 and pi over 2, that's going to give me a positive pi over 4. So now, what are these values going to be? All right, so when I take a look at the values of sine of x, so sine of negative pi over 2, that's going to be negative 1, right? And we can take a look at our unit circle over here, right? So I'm looking at negative pi over 2. That's going to give me a negative 1. But then remember that my function y equals, it's going to be 1/2 of sine of that x. So if I get negative 1 here, I still have to multiply that by the 1/2. So I end up with negative 1/2 as that first value. So here we're going to have negative 1/2. When I plug in that negative pi over 4, right, I am going to have, coming back over here to my unit circle, negative pi over 4, that's going to be this value here. So I'm going to end up with y equals 1/2 times negative root 2 over 2. Well, this becomes negative root 2 over 4. So that's the value I'm looking at. So I'm going to have negative root 2 over 4. Now at 0, right, when I'm looking at plugging in 0 for sine, I end up with 0. So 1/2 times 0, that just gives me 0. And so now, because now I'm on the positive side, that just basically means I'm looking at quadrant 1, right? I'm going to have the positive root 2 over 4, and then I'm going to have the positive 1/2. So these are the values. So once I have the values, remember, these are the values for my inverse function. So when I go to graph this, now I need to think, okay, well, I really want to graph the original function, so I'm swapping these again. So now this is going to become the y values that I graph on the graph, and these are going to be the x values I graph on the graph. So on the x, I'm going to start off with x equals negative 1/2, and then I'm going to go to negative pi over 2. So that's going to be, you know, if this is -1, so -1/2 is right here. I'm going to be at -pi/2, so I'm right here. At -√2/2, right, for my x value, I'm going to be at -4. So that's going to be somewhere like right here, right? At 0, 0, I'm going to be here. And then at pi/2, I'm going to be at +1/2 pi/2, and then this is going to be somewhere like this. So it's going to look like this. And this is the entire graph, because remember that we are restricted by this domain and this range. So because it's a restriction, notice that this is a graphed segment. We don't have lines stretching off from this. That is the entire graph. Okay. All right, let's take a moment and look at example 2 here. All right, class, when we are looking at example 2 here, we are looking at f of x is cosine inverse or arc cosine of x minus pi. So we think of just arc cosine, right? That range is going to go from 0 to pi, right? We can also look at this as the range goes from 0 to pi. Now, because we have this minus pi over here, and I do want to take a moment to acknowledge that parentheses are important. So this is saying one thing, right, which is now a horizontal shift. But here, because I don't have these parentheses, it's really saying the inverse cosine of x minus pi. So this is this negative pi here, that's going to be a vertical shift. So because of that vertical shift, it's going to transform my range from negative pi to 0. Okay, so that's going to be my new range. So we are going to be exploring negative pi to 0. Halfway between both of those is going to be negative pi over 2. Halfway between negative pi and negative pi over 2 is going to be negative 3 pi over 4. And then we have negative pi over 4 over here. So I wanted to start us off with some of those values, just kind of keeping in mind that shift and how that's going to be changing our range. Go ahead and do step 1, step 2, and step 3 for this function. All right, after trying that out, I hope that you found that the cosine inverse function, or the inverse function of the original function, is cosine x plus pi is inside of the cosine, right? So that's going to kind of come into play when we're plugging in our values. So for x, you know, if I'm plugging in negative pi here, I plug in negative pi, I get cosine of 0. So that's how we get this 1. And we're going to do the same thing for all of these outputs. Make sure to use your unit circle if you're having a little bit of trouble with that. Now to graph it, remember, we're going to swap the y and the x, and we're going to graph it backwards. So here is that point, negative 1 negative pi. Sorry, 1 negative pi is over here. And then we have our our point negative 3 pi over 4, right? So we can kind of see all those points coming into play here. At negative 1, we are at 0, so we're back over here. So this is what our function should look like, and this is the entire function, right? It doesn't continue, and this is matching our original range of that negative pi to 0. All right, let's look at arc, cone, tangent. All right, when thinking of arc tangent, right, our range is going to be limited to pi over 2, negative pi over 2 to pi over 2, and this is because that's where those asymptotes are located. So for the purpose of graphing, right, or plotting these points, let's go ahead and use them, but keeping in mind that they're going to be undefined at those points. All right, so let's go ahead first and foremost and start off by creating our inverse function. So we're going to have y equals, I'm just going to swap it over to tan inverse of x plus 2. Okay, so I'm going to take the tangent of both sides, so I get tan of y equals x plus 2. Actually, sorry, I forgot. You're supposed to swap the x and y first. I got a little excited there, but yeah, so we're going to have x tan inverse of y plus 2. And now we start solving, so we're going to end up with tan x equals y plus 2, and then we get tan x minus 2 equals y. So our inverse function is going to equal tan x minus 2. So this is what we're going to use to find those values. So halfway between negative pi over 2 and pi over 2 is going to be 0. Halfway between 0 and pi over 2 is going to be pi over 4, and then we have negative pi over 4 here. So when we start plugging in this value, right, so when I plug in 0, I normally get 1. So 1 minus negative 2 is going to be, sorry, I usually get 0. Plug in tangent of 0 is 0, and then I subtract that 2, so I get negative 2. When I plug in pi over 4, I get 1. 1 minus 2, that's going to give me negative 3. When I plug in pi over 4, I'm going to get negative 1. Right, so we're looking at these values. So now when we graph this, we do need to swap these out. So this, we're going to graph this as a y, we're going to graph this as an x. So we're going to come over here and plot these points. Let's go ahead and ignore these for a second. And so then let's start off with negative pi over 4 and negative 3. So I'm going to start off with negative 3. I'm going to go to negative pi over 4, so I'm right here. Then I'm going to come at negative 2, I'm going to be at 0. And then at negative 1, I am going to be at pi over 4. So now, even though these aren't necessarily graphed, the pi over 2 and the, as being undefined, we can think of it for the purpose of graphing as asymptotes that are going across this line. And this will help us just kind of create that curvature and those inflections and how our graph is going to kind of follow those asymptotes out. So this is what the arctangent function should look like in terms of our graphing. So still kind of keeping pace with those 3 steps and plotting those graphs. All right, go ahead and take a moment to try number 4. We're looking at cosine inverse of 1/4 x. Remember that when we look at cosine inverse, the range restrictions are going to go from 0 to pi. So when we start filling this out, we should be going from 0 to pi to fill that out. Go ahead and take a moment and try that out. All right, so we're going to start off by swapping our x and our y's here, or replacing y with f of x, and then we swap those. We're going to go ahead and find that inverse function, and we see that our inverse function is 4 cosine x. So starting off from 0 to pi, right, we plot in our values, remembering that when we plot these on the graph, we are swapping these for y and x, so that it helps plot those. And so once we plot those, you get your values. Once we plot those, we should see a graph kind of forming like this. Remember, this is the whole graph. It does not go on forever. This is it. Okay. All right. Hopefully this is coming together. Go ahead and try example 5. All right. So after attempting this, we should have seen that our inverse function is sine x minus pi over 2. And so we're going to go ahead, we had already filled out the range from 0 to pi, right? Because we see, actually, let's take a step back. So arc sine of x plus this pi over 2. So this pi over 2 is going to tell us that our range is going to change. So originally, sine goes from negative pi over 2 to pi over 2. But because we have this shift, and this does that is a plus sign there, we are going to add, right, pi over 2 to each one. So we're going to end up being with 0 to pi. So this becomes our new range. Right. So let's go ahead. We're going to start off with that 0 to pi, right? Because we're going to swap it for that inverse function. Find it here. Once we have this, we're going to start plugging in these values. So sine of 0 minus pi over 2, that's going to give us a negative 1, right? And then we're going to get the rest of these values. Feel free to use your unit circle as a reference, making sure that we are kind of changing that value. So if I'm plugging in, for instance, pi over 2, I'm doing pi over 2 minus pi over 2, which gives me sine of 0, which is 0. So now we're going to go ahead and re-invert those, right? So here's our y, here's our x value, and we start plotting those on our coordinate here. And so we should see this small little graph that goes from 0 to pi as our range as stated. All right, go ahead and try number 6. All right, so we should see here that our range for our tangent, our inverse tangent, should have gone from negative pi over 2 to pi over 2. So we're going to go ahead and start that off. Notice that we're not adding. We don't have any type of vertical shifts happening. So we're good with that. So we're going to go ahead and start this off with negative pi over 2 all the way to pi over 2. And then we start off replacing that f of x with our y. And then we're going to go ahead and swap the y and the x and go ahead and solve for y. And we get our inverse function stated here. All right, so now we're going to use this function in our unit circle to go ahead and fill out the rest of these values. Remember that tangent does have those 2 undefined values that we can use as asymptotes kind of coming across that pi over 2 and that negative pi over 2 here. So swapping our y and our x's, we plot these 3 points here and knowing that that tangent function is going to kind of follow into those asymptotes there. Okay, so then that's it. That's the end of this video.